This question is about nuclear stability. Explain which isotope is more likely to be non-radioactive or indefinitely stable, mercury-200 or thallium-200?
This example asks us to decide which of these two isotopes is more likely to be non-radioactive or indefinitely stable. So we know that there are two things that affect this. Number one is the neutron to proton ratio, and number two is the presence of odd and even numbers among the particles in the nucleus, the protons and the neutrons. So a quick check at our neutron to proton ratio shows that both these have approximately 120 neutrons to about 80 protons. So that's a ratio of about 1.5 to 1. We know the biggest atoms in the periodic table get up to about 1.6 to 1, and so also we can also check the mass numbers here and see that they're pretty close to the atomic masses, which gives us an idea that they are true to the 1.5 to 1 ratio that we would expect around this place in the periodic table. So this question obviously involves the odd and even numbers that are present in the particles in the nucleus, the protons and the neutrons. So if we have 80 protons here, the mass number minus the atomic number tells me we have 120 neutrons. In the thallium-200, we have 81 protons and 119 neutrons. So right away I see a big difference. The mercury-200 has an even number of protons and neutrons and therefore is favored. There's a very, very small chance among indefinitely stable nuclei of having an indefinitely stable nucleus if I have odd numbers of both protons and neutrons. So the mercury-200 is more likely to be non-radioactive due to an even number of protons and neutrons. So an intermediate case would be an example which has one even and one odd number among the protons and neutrons. It's almost as likely to be stable, not quite as likely, and this is the least likely scenario.